So in this class, we're going to discuss DNS records and messages, peer-to-peer application, peer-to-peer file distribution. So domain name system records contains the distributed database storing the resource records in the format of name, value, type, and time to leave. TTL is nothing but time to leave. So this is exactly in the distributed database of DNS server storing the resource records in the same format. So what is exactly a type? A. Type is equal to A. It is nothing but name is host name. So name is host name means so who is exactly communicating, which machine is communicating, that is a name is host name, and what is the IP address of the particular machine. Value is IP address of the particular machine. Again, another type of the records. So it is a canonical name, C name. C name is a alias name for some canonical the real name. So for example, so this is the domain www.ibm.com. It is a commercial domain. Is really a server so backup for .ibm.com. This is exactly so that is exactly the domain name. So with the name of the domain. So examples also given. So that is the canonical name. So here the value is canonical name. So finally ibm.com, that is exactly domain name with the extension .com is extension. So another one is type is equal to NS. NS so is a name server. So name is a domain, and also example, for example, it is exactly commercial food.com. It is a com.com is a commercial domain. The value is so host name of the authoritative name servers for this domain. So type is equal to MX. MX is nothing but it is a mail server associated with the name. So that is the value. So type is equal to MX. If it is a MX, the value that is the name of the mail servers associated with that particular name. So this is exactly the resource records contains. So DNS protocol messages. So as you know that query and reply messages. So query will be sent and reply will be get back from each of the DNS servers. So as a protocol, DNS protocol is sending a DNS request and as in the form of a query, and DNS reply messages will be get back as a DNS server will respond back to that the requested so either a DNS server to one servers to other servers, or it is a client to the so DNS servers. So this is how query and reply messages will be get. So both with the same format. Message header is identification of 16-bit. So the number of per query. So this is exactly the sum of the fields. 2 bytes length of identification. 2 bytes again it is a flag speeds and questions, number of questions and number of queries. Questions are nothing but number of queries is posed by either client machine or DNS server to other DNS servers in the hierarchy, and the number of answers in that. So that is a response RRs. So that is a so and authoritative RRs. So and additional RRs. This is exactly question number of authoritative servers response for the request. Here, questions are variable number of questions. Answers also variables number of hours. Authority is a variable number of RRs, and additional information is a variable number. These are the sort of that different fields contained in the DNS protocol. Here, so query to reply and recursion desired and recursion available. Reply is authoritative. So exactly, so authoritative. What type of query is sending? So authoritative servers, how TLD server, top level domain servers, how query and the reply will be sent. And recursion is a recursive queries. Recursion is available. And reply is authoritative. So this is exactly the some of the fields may contain. But similarly, so there is a protocol messages. So that is the name of the type fields, questions. So you can see that again the so same format, name and type of fields for queries. So this is indicate what question, what query is sent by the so either the requested person. So the questions and variable number of questions. So and also RRs in the response to the query and answers and the variable number of RRs and records for the authority servers authority variable number of records. So resource records RRS stands for resource records and additional helpful information that may be used, additional information it will be recorded in this field. That is the field indicates variable number of resource records. So here, so this is exactly the some of the various fields. So it is contains the DNS protocol and the messages. So inserting the records into the DNS. So example, new startup, for example, Network Ethiopia, register name networkethiopia.com. So at the DNS register and server. Example, Network Solutions provides the names, IP address of authoritative name servers. So whether it is a primary servers and secondary server. Registrar, so that is a DNS registrar, insert the two resource records into .com TLD servers, top level domain servers. So here network utopia.com. This is exactly .com. Okay, domain name DNSL network ethiopia.com. This is also domain name. So NS. So that is the name servers. So this is exactly the so again domain name with .com servers with IP address of the particular so domain servers and authoritative servers. They create authoritative servers type A records. So A indicates is the authoritative server type. So for www this domain.com type and also there is a mail servers MX record for the network ethiopia.com. So this is how inserting the records into the domain name system. So here, so attacks also guarantees for the domain name system. So what are the different types of attacks we can classify? So DDoS, denial of so distributed service attack. So here, denial of the distributed service attacks is a bombard the root servers with the traffics. It is not successful to the particular date. Even traffic filtering can be done. So here, traffic filtering. So if you are observed, so to the root servers, so we can what type of attacks exactly these occurs. We can came to know that. And local DNS servers cache and the IPs of top level domain servers. So they're definitely allowing the root servers. So it is exactly bypassing root servers are bypassing, and it is a even local DNS servers cache the IP address of top level. So local DNS servers above that it is a top level. In the second level itself, top level domain servers are available. So definitely it is allowing the root servers are bypassing these. So that is a top level domain servers. So even bombarding the top level domain servers. So root servers are bombarding. This is exactly the reasons. So they are not successful to the particular day traffic filtering. And local DNS servers will that is exactly that is bombarding the so IPs of top level domain servers. This run the how root servers can be. So with the traffics, suppose if the traffic will be more, how exactly these so causes attacks. Even now bombard the top level domain servers potentially more dangerous. So even if you top level domain, second level domain servers, top level domain, what we call as .com, .business, .military, so net. So that is all. So that is a domain name extensions. So particular servers are maintained. So in the particular .com, .net, .edu, so .military, .org. These are the top level domain servers. So that is a potentially more dangerous suppose it is a bombards. So because of delay while distributing the so services to the so distributing the services to from okay. So again bombarding the either root servers or top level domain servers. So it is a more dangerous. Again redirecting the attacks. So it is a man in middle attack. Suppose if it is a man, if it is a man is nothing but so that is a attackers or it is a hackers or attacker. So that person is a man in middle attack. Intercept the so whatever send queries has been intercept. So suppose it is a local, so that is a person or requested person sending a query to the nearby server, nearby the local server. So it is a directing the hackers or attackers. So intercepting but particular queries. So it is a man in middle attack. It is targeting machine is local nearby local DNS servers. Man in between exactly it is in between routers. It is that is a hackers or attackers. So intercept the queries. So that is attacks are guaranteed. That attack is called as man-in-middle attack. DNS poisoning. Send a bogus replays to the DNS servers. So that is some replay relays. Some relays has been sent. So that is in the form of a bogus to the DNS server, which so exactly it is a caches. So the particular okay. So the domain name into IP address into domain name. When we converting, some bogus information will be sent. So that has been poisoned by the conversion with the domain name into IP address into domain name vice versa has been done because already it is a domain name system itself is poisoning. So because of bogus release. So exploit the DNS for DDoS. So how do you exploit the domain name system for distributed denial of service attack? So set up queries with a spoofed source address or target IP addresses. So it is definitely requires some amplification. So that should be definitely we can exploit. So we can exploit. So we can identify distributed denial of service attacks. So you can send a queries, keep on sending a query. So who is exactly spoofing the source address, or it is a source address to the target address. So we can able to find out who is exactly we can exploit very easily. So this kind of distributed denial of services attack. So here, peer-to-peer architecture concerned. So as you know that always on the servers. So without interventions of the servers, the client cannot contact the servers. So client of one networks can directly contact with the a client. So or it is a peer of we can client machines we call as a peer. So peer is a capability of send that is a sending and receiving of messages. So uploading or downloading of messages, no always on the that is a servers. So in client server architecture, so always the client can contact with the servers. So through again through the servers can contact the other client, but here it is not possible. It is a direct peer one peer. Client itself is a peer has a capability of downloading and uploading the information. So each peer of one peer, one networks can able to contact with that without interventions with the servers contact with the next peer of another networks. So through the intermediate networks, so intermediate networking core devices like the routers, switches, or even the base station through which it is a wireless device can able to contact. Peer are incrementally connected to the changes of IP addresses as and when changing in the IP address and also intimated. So as and when connections. So it is happened and also informed to the neighboring peers. So this is arbitrarily, so end system are directly communicating the peer-to-peer architectures. One peer can also communicate with the other peer. So for other network, even within the networks or it is outside the networks. So this is, I think, in red mark they are shown in these networks of a car. So as a device of end system, it is available. It is as a peer. So it can communicate with the other network of a laptop. So through a base station, so via interconnecting devices, there is a connectivity so with the networking core components. Example, so the file distribution, that is the best example. How exactly file will be distributed. That is a BitTorrent is one of the application to communicate with that. So one pair with the another pair with the help of this application, file distribution or BitTorrent application. And also, so streaming, suppose if it is a multimedia, so data has to be sent. So there is a streaming applications are supposed to be used. So that is the application has been developed already. That is a Concon. It is a one of the application for audio and video streaming. So suppose if it is a so you want to upload or download the audio and video information, you can use the applications like Concon in the one pair among the other pairs. Definitely. So upload the audio and the videos. So among one pair of one network, another pair of another networks. So again within the same networks. So that is possible in the Concon application while streaming the audio and video type of multimedia applications. Again, voice over IP with the help of Skype application. So telephonic, so internet telephony it is possible. So voice over IP is internet. How exactly conversation is possible in the telephone lines. So in the similar way in the internet environment, so we can conversation has been possible. So using voice over IP, so that is exactly just voice communication with the internet environment. So with the applications like Skype applications supposed to be used. So definitely how exactly in telephony we are conversation is possible between sender and receiver or caller and callee. So here also in the internet environment, so caller and callee can able to communicate. So till the terminating the connections. So here file distribution, client server versus peer-to-peer. So the question is how much of time to distribute the files. So that is the file size is that F. Generally we say that it is a file size F from one server to n piece. So that is the question is arises how much of time to distribute the files. So that is a peer upload or download capacity is limited to the resources. So you see that server upload capacity. What is the server upload capacity? So for all the so that is a so clients which are connected across. So this is the client server architecture line. So client server versus peer-to-peer we are comparing. But if it is a server, how much of time to take to distribute the file size? We have of one server to the n peers. Assume that this is the n peers which are connected 1, 2, and this is the ith peer. This is the n peer. So this is how in the network. So abundant bandwidth. It is this is the file size. So the assume that file size is so you can see that. So how exactly we can calculate. So here server transmission must be sequentially sent or upload the n file copies. Time to send a one copy. So they are calculating how much of time it is required for one file to send by the so particular server so for uploading. Use stand for uploading or time to send n copies. One copy they are calculating and time to send n copies. Later on it is calculated by n copies. Suppose it is a one copy if you have calculated very easy to so 10 copies or 20 copies if we are calculating the time. So we can easily calculate it. So how sequentially upload that. So that is the end files. So here each client must downloading the files. How much of time it is required to download that whenever uploaded the file. So it is received by each of the clients. How much of time it is required. So here minimum downloading, this stands for downloading time. Minimum client to download rate is, minimum client download time is so file. So whatever the file divided by so downloading in terms of minutes. Time to distribute the files. This is exactly so generalized equation. Time to distribute the F to N. So F is nothing but file to N clients. So using so client server approaches. So that is exactly distributing that. So client server always if it is greater than so are equal to so maximum of this. So that is a N okay N copies of the files. So F is a file. So divided by what is uploading by the servers. So comma. So the file. So divided by so what is the minimum client download rate. So that should be. So it is increased linearly. So this in n. So that is exactly is here file distribution. What is that? They are comparing with the file distribution time in peer-to-peer architecture. So server transmission must be upload at least one copy. So here it is a so you must be upload at least one copy. The time to send one copy it is already you have calculated file. So that is so one copy of the file divided by so what is that so the so uploading of so stands for server. So each client must downloading the files. So you know that it is already so minimum client downloading time is divided by so d minimum rate. The client is aggregated must be downloaded. So that should be a maximum upload rate limiting to the maximum download rate. So that is a so upload plus so that is a limited to the maximum. So that is exactly yes divided by you yes you into so 8s multiplied by so uploading. U stands for uploading. So to the ith page. So here time to distribute the file. So F is the file to the end clients using peer-to-peer approach. So that you have to take so D peer-to-peer greater than so are equal to the maximum of so comparison of this file divided by uploading of servers, uploading of downloading of D stands for downloading minimum. So that is a client. So This is exactly so n into so n copies of files so into divided by so US stands for this is they have taken so US and summation of UI okay so that is the limiting so maximum download rate. This is the UI. It is a summation of all maximum downloading rate they are taken into consideration. So it is increased linearly so in terms of n copies. But so does this each peer brings the service capacity. You can see that in the so the next slide, client upload rate. So you can see in the graph. So normally in the client server approaches, it is a so this is a black line. It takes maximum time. So minimum distribution time from the server to the all clients. It takes more than three. Okay, so minutes. So three more than 3 minutes. You can see that is increased linearly. So as and when so number of copies are more, it is increased linearly in case of client server approaches. But in case of peer-to-peer approaches, so that is exactly that is a zero point 0.5. So nearer to so point, so that is a 9. Exactly, it is in case of so which so it is in the peer-to-peer approach. So uploading and downloading the so the particular file or distributing the particular file from one peer to another peer. So the time so the distribution time will be less in case of peer-to-peer approaches. So this is exactly in the blue lines indicated so that so that is almost it should be a constant rate. So here, as and when number of copies are increased, it is keep on increased linearly. So with the zero point 0.5, so 0.1, so again 1, 1.5, 2, 2.5, 3, 3.5 like that. As the number of copies are increased, so definitely it is increased linearly. So in case of client server approaches, but in peer-to-peer approach, so almost it leads to so 1, okay, zero point 0.5, zero point 6, point, so like that it is exactly. So that is so time. So minimum time distribution time is less in case of peer-to-peer. So that is the architecture. That is what we have learned in this graph. So in this class, we have discussed about DNS records and messages and peer-to-peer application and peer-to-peer file distribution.